Okay, this is a diagram of the EGR system in general on the 96 Avalon, and the year models in the mid to late 90s year models for Toyota, at least in the Avalon, this is a very similar setup on the 3-liter V6 engine. So in this particular diagram you have the EGR valve assembly, which is the EGR valve. You see the piping here. You have the EGR modulator assembly, which is mounted just on the other side of the valve diaphragm, and it's on actually a little bracket that attaches to the EGR assembly. Right down here is the temp sensor for the EGR system, and this screws right into the body. It's the iron type body here, piping. This screws right directly in and then plugs up to the engine harness here. So anyway, we're going to be dealing with this right here, the temp sensor, and what we're going to do is test it according to the Toyota testing procedures, and we're going to find out whether this is actually going to be a good temp sensor that I have on the vehicle, or if I'm going to have a new one. Okay, on this diagram, this is a setup of the testing procedure for the EGR temp sensor. You can see that the temp sensor here is dipped in heated oil. This is a thermometer here, so what I'm going to use is vegetable oil and heat it up over the stove. But this sensor is going to be heated, and as it's heated, we're going to measure resistance using an ohm meter. As it reaches certain levels of temperature, we're going to see if the resistance values are within that range that they're supposed to be in at that particular temperature. So this is just a little quick diagram of how this is going to look on our testing. Alright, now this is the values, the actual values that we're looking for, and when we're using the ohm meter, we're going to heat this up to 122 degrees. Somewhere around 122 degrees it should be 64 to 97 k ohms resistance value. As it's heated up further to 212, it drops to 11 to 16 k ohms. As it's heated up even further to 302 degrees, it should be 2 to 4 k ohms in resistance. So it's going to be steadily dropping the hotter the sensor becomes on this EGR sensor assembly. Now, if the resistance is not as specified, you replace the sensor. So it's that simple. Now, starting off, this is room temperature of about 74-75 degrees. So the resistance values of a, let's say, cold temp sensor is going to be somewhere in the 220 to 250 k ohm reading. So it's going to be really high when it's cold and at room temperature. So from 220 to 250 k ohms, we're going to be starting out there, and then we'll see it should continually start dropping as it heats up. So that's the idea, and we're going to see if it follows these parameters and try to determine whether this is a good sensor or not. Okay, this is the way I have it set up. This is the oil that I have in just a small pan. I've got a thermometer set up. This is actually a gunsmithing thermometer that's used in metal finishing, so it goes to pretty high temperature readings. It'll read as high as 400 degrees, which is what we really need to have, since we're going to have 300 plus degree readings hopefully on this as we're testing it. So I've got it set up in a little candle, little jar, glass jar candle here, because it works good with the clip. And I've got the probe just inside the oil there, not touching the bottom. It's kind of suspended right in there in the oil, so to get hopefully an accurate reading. If you have a third hand, this is really handy to use, because you can clip this onto your temp sensor, so you can have your hands free to do other things while this thing is being suspended in the oil and heated up. I also brought a laser temp display just to see what consistency we have between the thermometer and how accurate it is. So this is reading about 74 degrees on the thermometer right now. And let's see if I can bring it over here a little bit. Okay, that's about 74 degrees. With the thermometer, it reads about 77. So it looks like we're in pretty good shape. 76. So it's pretty consistent. what we're going to do is heat this up starting now. Now as you can see the reading, sling this over a little bit, the reading right now is 237.6. That's the current reading that it's getting. So in K ohms, 237, almost 238 K ohms when it's at room temperature, the sensor. So it's in that range when it's cold. What we're going to do now is actually ease this thing into oil and start heating up the oil. Okay, I'm suspending it in the oil. I'm not touching the bottom. It's just going to be suspended in the oil about halfway in there. And you can already see the resistance level is dropping. It's coming off of 237 K ohms and it's already dropping. And the reason for that is the oil temperature is showing about 77, 78 degrees. So it's actually a little bit warmer than it was in the outside air. Alright, we're going to turn this on. And I'm going to go ahead and turn it into the high position on the stove. Heating elements up high. Now, as this heats up, I'm going to go ahead and bring it over to you so you can see the thermometer. And I'll check it periodically also with the laser thermometer. It's climbing up a little bit. It's hitting 80 degrees on the thermometer. So what we're looking for right now is we're looking for that 122 degree mark. Now something, as it's heating up, I just want to point out that this setup right here, this is an oscilloscope, but I've got it set on multimeter setting. But the alligator clips work really well. I have these extra leads. These are terminal test leads. You can buy those off of the Tool Guys, Snap-on, Matco. You can get it at Radio Shack, I do believe. But these are basically terminal test leads that you can use. They come in male, female, pin type configurations of different shapes and sizes. And this is great for testing terminals, terminal connections, things like that on your vehicle. It's great for just hooking those up to a connector like you see here, and like on this connector here, hooking it right into the terminals, and the other end clipped directly to your multimeter. So it makes it nice and convenient and a lot simpler to work with, and not having to use both hands to hold something while you really need your hands to do something else. So right now we're at a little over 100 degrees, and I'm going to show you the multimeter reading. You can see it's steadily dropping. And it's already at 33 K ohms, climbing up there quite. And you can see we're already at 10 ohms. So I'm going to cut this down. Alright, I'm just going to go ahead and turn it off. And we're at about 302, 307, 312. So let me show you this. You can see it's about 324. When it hit into the fluid, it's about 3, it's ranging. So 307, 312, 290. So it's in that range. Well, it's showing 3.75 K ohms. And at 302 degrees, it should be 2 to 4 K ohms. So it's right on the money. But I'm going to say we're good because we're sitting at 2 K ohms and it's above 300 degrees. So that's where it should be. Now it's cooling back down. So as it cools down, it's going to be raising, the K ohms are going to be raising back up. So overall, I'm going to say this is a good sensor. There's no indication that it's giving wrong readings. It's 300 plus degrees and it's showing very low on the K ohms, no problem. And it was correct on the K ohm reading, on the resistance reading when it was cold. at around 230 k ohms, so I'm going to say that's good too. Starting with it cold, you want to know what the value is. In this case, it was around 230 k ohms. As it starts to heat up, when it hits around 122 to 125 degrees, it should be at about 65 to 97 k ohms. As it moves on up to 212 degrees, it should be 11 to 16 k ohms. It's dropping. So as you're moving on up to 300 plus degrees, you're looking at 2 to 4 k ohms on your resistance values, resistance readings. So as long as you're following a consistent pattern as it's heating up and as it's cooling back down, you really don't have a problem with your EGR temp sensor. There is one side note on this temp sensor. When you check it, if you check it in the vehicle, if you disconnect this connector from the vehicle engine harness and you want to do a resistance reading on these two terminals, with it installed in the engine, if it is 600 k ohms or basically less than 600 k ohms, then it should be okay. If you have a reading that's above 600 k ohms, more specifically 720 k ohms or more, then it's going to be considered an open circuit and you've got a bad sensor. But as long as you're reading somewhere below 600 k ohms, it's typically going to be an okay circuit. But to be sure, you want to do the oil test, the heat test that we just performed, to make sure that it's reading correctly in all the ranges from cold to hot, hot back to cold. So that's just a little side note there. But an open circuit condition, it should indicate 720 k ohms or more, and that'll indicate open circuit and a bad sensor. Okay, when you're finished with this sensor test, checking whether it's good or not, you want to also check the engine harness side. And what you'll do on the engine harness connector, you'll have your two terminals here. You want to put your voltmeter on the two terminals on the engine harness side, and when you do that, you turn the ignition switch to the on position. Don't start it and run it, just turn it to the on position, and you should have 4.5 to 5.5 volts showing on your engine harness side. So as long as you have that voltage showing, you should be okay on the engine harness side as far as feeding the proper voltage to the sensor for the correct readings by the ECM. That 4.5 to 5.5 volts is a reference voltage that the ECM uses to measure the actual output that this sensor is providing. As the resistance changes, that voltage is going to change. Then the ECM will detect that and it will convert that into a signal for the EGR system to use. One last thing to check when you have this reinstalled and everything is reassembled on your vehicle as far as the EGR assembly goes, start your engine, run it up to 4,000 RPM for 3 minutes. You want to have the temp sensor disconnected, just like this. You also want to have the VSV, the vacuum switching valve, disconnected also. And run it at 4,000 RPM for 3 minutes. That will get some exhaust gases up through the exhaust gas tube, the EGR tube, and start heating this sensor tip up. After that period, measure the resistance value of these two terminals and make sure that you are 4.3, about 4.5 ohms, k ohms or less. That'll tell you that it's functioning properly also. So that's kind of like one last basic check after you've already done the more specific resistance range testing using the hot oil method.